Hello, everyone. Welcome to yet another live coding session brought to you by Harmony. This will be our second live coding session for the 4 cohorts. My name is Agilo Christian. I'm the Assistant Programs Coordinator at Harmony and also a data scientist. Thank you all for joining. Okay, this will be our live coding session for this stage B cohort. And this is geared towards data engineering and data science track. So other track members are also welcome to join. So, all right, without wasting time, we already have few participants also on YouTube and here. I'm just start sharing my screen and we'll get down to the business of the day. Okay, what we'll be doing today basically will be an end-to-end machine learning coding, that's regression, machine learning regression coding. This is basically what we'll be doing in this stage B course. That's regression analysis, doing your analysis, running your machine learning model, using your mean absolute error or your RSS and other metrics. So let me just share my screen and we begin for the day. Can everybody see my screen? Just signify by dropping it in the chat. Okay. Okay, good. All right. Today we'll be dealing on machine learning regression modeling and analysis, and we're working with the data sets, which is the my favorite data set I always like using cars data set. Okay, I've already written down some of the code, so based on time, and also I'll just be explaining the codes as usual. All right, before we begin, in machine learning, there's regression, that's under the supervised machine learning. There's regression, there's classification analysis. So today we'll be dealing on regression analysis. And regression analysis, let me just explain it. Basically in machine learning, it's probably dealing with numbers. You're predicting the price of commodity price of cars, predicting the price of the building. So basically it's just numbers, unlike classification whereby you're predicting if this, the difference between this or this, if it's 1 or 0, if a person has a disease or not, if a person is going to subscribe to this particular campaign or not. So that's classification, but we'll be dealing with regression analysis. So I'm not going to dwell more on the theory aspects, just go straight to the code. All right, let's begin with our first line of code, which is to import the, mind you, I'm working on my collab, so this is not Jupyter. So I run the first line of code, importing pandas, NumPy for numerical analysis, Seaborn for visualization, also matplotlib and all that. So loading the data sets. Mind you, this data set, it's a, okay, let me just read it. It's a cars data set, yeah. It has different columns, like the previous sessions we had before. You understand the data frame of a data set. So what we're going to be predicting with this data set is to know the amounts that will be sold, that a particular car will be sold from different other specification of the car. So different columns will have the location, the maker, the model of the car, the year it was made, the color, and all that. So, but this our amount column will be our target column for the day. And viewing the data sets, we have the data set, we have 9 columns and 7,205 rows. So this is a much larger data set than one we had in our previous class. So, and also to just start, I'll explain more on the process of working with the machine learning. That's the workflow, machine learning workflow. And we'll be using scikit-learn library, the algorithms in scikit-learn. So I would show you how it's done or how the workflow is from the documentation and a particular algorithm you have to use for a particular number of data sets you have or particular problem you're solving. So before we get to that, let me just work on the analysis of data sets to clean the data sets and to process and whatever. So if you notice this, our data set here, this year column, this is supposed to be a date time column, that's a year, but it's numbers, that's integers number, but this comma sign, this is supposed to be a year 2011, 2012, but there's this comma sign here, and I don't want that. So I'm going to clean it by replacing it with an empty space. So this would be 2011, not 2 with the comma. Also, there's this distance column, the same thing. I want it to be just straight numbers without separated by a column, comma or whatnot. So I'm going to be cleaning that, replacing it with this, using this code. Since I'm calling the year column and the distance column, so I'm replacing the comma with an empty space. So this will just be 2012, 2010 with both columns. So there's a code in Python whereby I can use called replace. So since it's a string, that's why I can work with this. This is a string. If it was an object, it won't work. So I'm just going to run that. And let's view the okay. I think I had slow network there. Okay, so what I did is I just removed the comma from it. So this is not like a straight string with the year 2012 and all that. Then I'm going to run a code called df.describe to see my metrics in my data sets. This is the count, the mean, the standard deviation, and whatnot. Okay. I'm going to check my info. Remember, we've done this code before, so you should know what I'm doing. df.info. This will show me the data type of my data sets, the number of columns, number of entries, the rows, and whatever. So if you notice, the only column in this data set that is a number, that's an integer, is this amount. Whereas this year column is number, but it was saved as an object when probably by the data engineers when getting the data set. So when we move further, you understand what I'm trying to say about that. Okay, then checking if there are missing data in our data sets. Yes, there are missing data in the year column 12, amount column 17, distance, we have 2,360. So while I'm working with missing data, there are different ways of doing this. You can check if the missing data in that column is probably small compared to your full data set. If you notice our full data set has 7,250. So if the missing data for the year column is just 2117, you can just drop it. That's another way of doing it by dropping the missing data. There's a code called drop now. But this distance column, we have 2,260, so we have to fill it. But still, I won't be dropping any of the missing data. I'll just be filling it. A different method of handling that. Okay, so all right. let me explain this code here. I'm handling the missing data. For the year column, we had how many missing data? 21. So I'm going to fill it using the median of the whole column. I'll fill it using the median. There are different ways you can use. You can fill it with the mean or with the mode, but I chose median because it's more robust. Then for the amount column, I'm filling it with the median also because it's a number, it's an integer. Then for this type column, why I can't fill it using fill now? Because the type column is an object, which is this. It is not numbers. Here's my type. Yeah, it's an object. I can't just fill it using mean or mode or median. So there are different other ways of filling it. There's something called the forward fill or the backward fill. And just go back and browse on how to handle missing data, how to fill it, dropping it, or how to handle them. So that's what I'll be doing for this type column using the forward fill. And the meaning of the forward fill is, for example, let me go back to my data sets. If you notice there's a missing data here, which is none. The forward fill, what forward fill does is that it will fill the place I have a missing data with the previous data. So for example, since this one is none, it will fill it with this 200,000. And there's another method called backward fill. Instead of forward fill, backward fill, it will fill this none column with this 85,000. So that's the meaning of forward fill or backward fill in Python. So moving on, let me just run the code and you'll see what I'm talking about. All right, lovely. So let's check if we still have missing data. So voila, we've handled all the missing data, no missing data in our data set. So moving on. So we have in our column before, we have objects and only one column to be a float, which is a number. So before you pass the data to machine learning code, it has to all have to be in numbers, that's ones and zeros, just like in computer, you know, it works with ones and zeros. It doesn't work with an object data like vehicle ID or a location, which is not a number. So we'll have to convert these columns that are objects into integers. So that will be my next code. So I'm working with this distance column and the year column. There's a code in Python called as type. So I want to change this as type to a float or an integer to numbers, the year column and the distance, because the distance and the year column from the data set is showing objects. It's showing objects, but the way it was stored is numbers. This year column, these are numbers, right? But it's showing as objects. So that's why I can just change it to a float because it's already numbers. I don't know if you understand. If I go back to the code, you understand what I'm trying to say. So I want to convert this to float and integer. So if you see running the df.info again, it has changed to integer 64 and floats, that's this distance and year column. Those are the only categorical categorical column I can convert. Then the other column, which are objects, I have to handle it also to convert it to numbers. There are different ways of converting it. You have one hot encoding, label encoding, column transformer. I'll get to that place so you understand what I'm trying to say. All right. Working with this data set, I don't need the vehicle ID column. It's not necessary. So I'm going to drop it. Or ordinary encoding, yeah. That's correct. So there are different ways of handling or converting your data to numbers. So I'm going to drop in the vehicle ID column. I don't need that in my machine learning algorithm. Then checking my full data set. So I only have the location, the maker, the model, the year, the color, the amount, column. So that's what I'll be working with. Because I'm doing this because it's not important in or it will have any effects in running our machine learning model. So I'm just dropping this column. All right, moving on to the modeling aspect. like I said, I want to get the categorical data and the object data. So I'm using this code. I'm using this code to get my two, all this is doing to just get to select my object column are the location, the maker, the model, the color, the type. Those are the object column. Then the categorical column, the categorical column are the location, the maker, the object. Then the number columns are the year, the amount, the distance. So these are numbers. So, okay, now I want to preprocess the categorical columns, which are objects, into numbers that the machine learning model can understand, basically. So I'm running it with this code called label encoder or one-hot encoder. So, but what I'll be using will be label encoder because, let me go back to the data, you understand why I'm trying to do that. Using label encoder, in this maker column, for example, we have different types, the Honda, the Hyundai, the Lexus, Mercedes-Benz. What label encoder does that it will give them a particular numbers. So this Honda column might be 1, the Hyundai might be 2, Lexus might be 0. So instead of using, there's another code called get dummies in pandas. The difference between label encoder, one encoder, or get dummies is that get dummies, it will create a new column. So the data set will be more, or yes, there will be more column. But label encoder, it will just change it to numbers inside the same column. So that's why I like using label encoder. And it works well, for example, if you have a data set that the gender will have male or female. So male might be 1, the female might be 0. So it will still put it under the same column instead of creating a separate column for it. So moving on. Exactly. All right, so this will just transform our data that are objects into numbers. You see now, this location before we have different location labels, whatever, so that just change it to numbers that the machine learning algorithm can understand. So this model changes to the numbers, represented each of them to numbers instead of creating a different column exactly for it. So I prefer this is making more sweet and clean. All right. In this stage B, we're dealing basically with just linear regression, which is multiple linear regression. In sklearn library, there are different types of regression algorithms. There's the linear regression, there's the ridge, SVR, k-neighbors, decision tree, random forest regression, cat boost regressor. Let me just go to the sklearn so you understand what I'm talking about. sklearn. Cheat sheet. Okay. Okay, no, this is not. I want to show you how to select the algorithm for a particular data set. Okay, this is what I'm looking for. So choosing the right estimator. Okay, let's consider this part of my screen. Okay, yes, fine. I'll get back to your question after I'm done. I'll get back to your question about that. I'll explain that. Okay, for this is the sklearn documentation of how to use the particular algorithm for different problems. So if you notice here, there is the classification problem, regression problem, dimensionality reduction, the clustering. So basically, we're working with regression. So let's start using this roadmap. yes or no. If it's no, we get more data. So for this, our data set is over 7,250. So yes. So moving on, are we predicting the category? No, we're predicting numbers, not category. Category is either yes or no as labeled data. Then are we predicting a quantity? Yes. So the amount of then moving on with the roadmap. Is our data less than 100,000 samples? Yes, it's less than that. So moving on to the next roadmap, we said a few features should be important. Yes, few features should not necessarily be important. So you can either decide to go no or yes, but this time I'm going no. So that's how you know how to use a particular algorithm for your data set. So this is just like an easy roadmap. But basically, I tend to select based on I know what I'll be doing, so I tend to select the algorithm that I've already used before. So the essence of using different algorithms, although it's computationally expensive because you cannot be running so many algorithms, but what I do is just try to sample different algorithms and see the one that is best for my particular data. That's not overfitting or underfitting or having outliers or noise or whatever. So this is just like a sample showing you the different roadmaps in sklearn library. Okay, back to our code. So I'm selecting the different regression algorithm. Yeah. So let me just install CatBoost since I'll be using it. This is a type of regression algorithms sklearn. So you can just go back to the documentation. You get to know the different algorithm in regression. So I'm importing the different ones I'm using. Then my metrics, which is the R2 score, the mean absolute error, and the mean squared error from scikit-learn and train test splits. Okay, running that. Okay, in excuse me, machine learning, yeah, you have to split your data into the X and Y. That's your dependent from the independent data. So my target variable here is the amount column. I'm trying to predict the amount. So I'll drop it from the total data set, that's this column. Then the remaining data sets. Sorry, yes, my S data would be my full data set except this amount column. Then my Y data will be my target data set, target data, which is dependent or independent. So running that, these are part of the documentation in sklearn. Then I'm splitting the data into train and test sets. Train set, testing set. This is just part of the documentation in scikit-learn library on how to run a machine learning model. If, for example, you are working with a data set that you don't have a separate test data, you can train your data using a train and tests, train test splits. Yeah. So you're training it some parts of the data and you're testing it with some parts. So now I'm testing it with 20% of my full data, then training the other 80%. So this is just part of the documentation on train test splits, your S train, your S test, your Y train, your Y test. So run that code. You run the next code. So these are our shape of our data sets. Then this next code I'll be running, yeah. Let me just explain. Since I'm using different amounts of regression algorithms, so I'm putting them in a dictionary called models. This is just like personal code. And I'm setting up a function to fit and score it because there's something called in coding generally, you have to avoid redundancy. That's writing a particular code over and over. So for example, I want to do this. I run XGBoost regressor. I saw the results. I go back and run decision. No, instead of doing that, I'm putting it in a pipeline. So this is what I'm just putting everything in a pipeline called models. So those in data engineering track, when you go for the probably stage C, you understand more of pipeline, working to Azure and well. So I'm just putting your data in a form like a pipeline in a dictionary rather. So then I'm creating a function that will fit and score the data. So this looks like my function I created. Then I'm setting a random seed. This random seed is for reproducibility. If I'm running this code again, to give me the same numbers. So if I did set this random seed, every time I run this code, it will constantly give me different numbers. So random seed is for reproducibility. And I'm using this code to fit the data, this to return scores of data. So this is what this particular line of code is doing. This is like a pipeline I just created. Instead of running everything every time, I just want to put everything in a pipeline and I'll call this function and to give me an answer, which is scores function. So let me run that particular code. Then moving on, let me call the function I just created. So this time around, this is going to run the algorithm, all the algorithms together, and at the end of the day, give me a final answer of all my algorithms. As you see, it was very fast, run data. So this learning and whatever is showing here, this is for the cat boost. This is how cat boost show you that what is running, learning in this algorithm. So that's that for that. Then the answer I got for each of the models, that's the algorithm I'm using, these are the answers. Mind you, in machine learning regression, the default evaluation is called the R2 score. In classification is the accuracy. So for this, these are the R2 score, that or R square score. So for HDBoost, we got 0.85, 0.6 for decision tree. So let me just put it in a visualization so we'll see which one was our best model. You notice linear regression didn't do well with this particular data set. So that's why you have to understand your data sets before you know the algorithm to use. And normally boosting is always the best most times. So, but sometimes you can see that when you know how to handle underfitting or overfitting. So let me just compare them, putting it in a visual. This code will show me them, will show me my data, my algorithm in visuals. So from this visual, you know, the best model was this cat boost model. SVRO didn't do well. Linear regression model didn't do well with this particular data set. So the R2 score was 0.2. So when we get to the metrics part, I will explain the meaning of the importance of the R2 score, or the mean absolute error, or the mean squared error. So I'll select the cat boost model. So with this, instead of me running my different codes to check which is good or which is bad, so I just, as I did this in a pipeline, it was just easy for me to get everything at once instead of running the codes over and over. So that's the importance of putting your code in a pipeline. So to avoid redundancy. All right, so I'm choosing the cat boost model. To just run that again separately. Then to score it, I had a score of 0.87, which is not bad, actually. I'm going to make predictions. To make predictions, you call the model dot predict. You are predicting it with your test data. Remember, we split the data into train and test. So we train it with 80%. So I'm going to test it with 20% of the data set. And these are the predictions it got. I'll put them in a data frame so you see, you understand better. So let me just go to the evaluation metrics, how to evaluate your model. So we have the R2 score, which is pronounced as R square, that's coefficient of determination. What this does is it compares your model's predictions to the mean of the targets. Values can range from negative infinity, which is a very poor model, which is 1. For example, if all your model does is predict the mean of the targets, the R2 score would be 0. So that's pretty pathetic and bad. But if the model predicts it perfectly, the R2 score will be 1. So the way you know how your model is good, from 0 to 1, if your score, like we saw, the linear regression was 0.2, so that wasn't really good. So for the cat boost, we had 0.87. So it's trying to at least predict it in a good, giving us good predictions. I'll get to your questions after the session. And if this notebook will be made available, I'll let you know. All right. Then to the mean absolute error, which is the mean, is the average of the absolute differences between predictions and actual values. So it gives you an idea of how wrong your predictions were. So that's what mean absolute error is, the average of the absolute differences between your predictions and actual values. Then while the mean squared error is the average squared differences between the predictions and the actual values. If you are squaring the errors, removes negative errors. So that's why you're using mean squared error. It also amplifies outliers, which have larger errors. So it will just, that's what mean squared error does basically. So I'm not going to go straight into the theory. Let's just go to school. So looking for the mean squared error of our data, of our model, then you run the square. It has 9.22, which is not bad. Then looking for the mean absolute error, it's 3.07. So meaning for this mean absolute error, it means that our model achieves a mean of 3.07. On average, our model's predictions are 3.07 units away from the actual value. So let me just draw a visualization so you see what I'm trying to explain. So this is it. Basically, this code is, I'm putting them in a dictionary, like in data frame, the actual values of the amount we had in our data set to what our machine learning model predicted. So if you notice, the actual value was 6.5, but the model predicted 8.4. So it's like the difference are like 3. That's what your mean absolute error does. Then this, the actual of 56, model predicted 51. That's the amount. Mind you, these are the amount column in millions. So the actual amount was 56 million. The model predicted that the car will be sold for 51 million. So this one was also perfect, predicted that instead of 2.5, predicted it will be 2.9. So this is what the mean absolute error does. It shows you how many your model prediction, how many units are they away from the actual value. Okay, let me put another visual so you understand better from the actual values and the predicted values using the scatter plot. So if you notice, from this visual, mind you, this might be outliers from the full data set. So the red is the predictions that model did, the blue is the actual value. So if you notice, the predictions are not that far away from the actual value. So this is what this visualization is just showing. I'm using a scatter plot to see how close the predicted value and the actual value are. Then this part I'm going to do is not actually part of the coursework, but I'm just going to add it. There are something called feature importances. So these are the features that are important to your model. For example, which of the column or your data is having much effect in your algorithm. So there are ways to find that. After this is a coding scikit-learn algorithm. So from your model, just do model.feature importance. It will tell you it will bring out an array of the features in your column that are important to your model, that affect it more, that makes your model predict what it predicted. So since we don't understand basically numbers, I'm going to put them in visual. So this is where data visualization come into play for those in data engineering track. So let me just explain this code shortly. So I'm creating a function to plot the features, that's the column, the importances, and sort their values, put them in a data frame, then plotting a bar plot to show these features that are important. So this is just like a code, a function I created to give me that particular visual. So once you improve more, you know that it's important to create functions. With time, you get to understand it's important to create functions instead of running code over and over. Just that function can make it to run different kinds of codes. So let me just run the code, the function I created, plot importances. So this is giving me a visualization of my feature importances, which are these array numbers. So from this visual, the year column was the most important feature in our data set when we run it with our algorithm. The location wasn't that important. So basically, if I want to run this machine learning, create a machine learning model, I can actually drop this location. It will not affect my model. So if, for example, I drop the year column, it will affect it in a way how it will predict. So this year column is the important feature in this model. So let me go back to the data set, the year column. So if mind you are predicting the amount of a car, how much the car will be sold. So using different features, we have a location feature. If it's in Abuja, this data set is trying to like states in Nigeria. For those outside Nigeria, Abuja is a state in Nigeria. Then the make, then the year. But for this our data set in our model, the feature that was more important was the year column. So with the year, it will determine how much the car will be sold for. So that's why from our model, it showed that the year column was the most important feature in our model. So this is just basically some few points in machine learning regression that I just ran through on cleaning the data, pre-processing it, removing missing data, drop categories, putting in category and objects, converting them to numbers that the machine learning model can predict. It cannot, if you run this data straight into the model, it will run error because it cannot predict with objects. So you have to convert it to numbers. So that's why we did the label encoding on the one-hot encoding. After which we split our data into X and Y. Then we fit and score the data, make predictions. Then I choose a particular data algorithm that was best. Then I did my evaluation using the mean squared error and the mean absolute error. There are other evaluation metrics. There's the mean squared error, mean absolute error, mean squared log error. So there are different evaluation metrics for regression analysis. For classification analysis, there are also different evaluation metrics. When you get to stage C, you get to do that. There's the accuracy score, the F1 score, the other metrics there. So I'll explain that when we get there. So basically, this is an end-to-end. And mind you, we're not deploying this. We didn't deploy this model. So it's not completely an end-to-end. End-to-end, after you've seen the model, deploy it to test it with a foreign data to see how your model would behave. It's cool or not. So basically, this is just it for this particular session for today. That's just it. So let me get down to questions in the chat. Okay. Stop sharing my screen. All right, if you have any questions, just drop it in the chat. Okay, I can see some questions already. If this notebook will be provided, yes. If it will be provided or not, we'll drop it in the Slack channel. But I'm not sure if it will be provided, but I'm not giving any promises yet. What's the essence of using many models? Like I said, personally for me, yeah, since I already know, sometimes if based on how often you created models, you ran your algorithms, you know which particular model is best for a particular data set. Yes. For this regression algorithm, like I showed you the roadmap of the scikit-learn library. Mind you, this is a supervised machine learning problem, and it's under the regression part. So computationally, it will be computationally expensive to run many models. But what I just did is to test a different regression models to see which would be best for a particular data set. So that's just what I did personally to get, and we saw that it was CatBoost that was best for this particular data. And I just used that to make predictions because it was best. And also, the other ways to know, you can do hyperparameter tuning. So that will be in stage C. Then you can do penalization, which is to remove overfitting or underfitting or whatever. And that's just what I did. Okay, another question from Goodrich. Yeah, I really don't understand how year is an important feature. What if we want to predict for next year? Are we including the year as a feature? Okay, no. What we did basically with this particular data set, the model, it was a model that predicted that the year column is the important feature after running this whole data. For example, we have another data set that have different columns, and we'll pass it to the algorithm. So is this algorithm that determined that, okay, this column is the important feature for this particular problem, that data set. So if you notice, the code I did was I used the CatBoost model dot feature importances, and it showed that it was year column. And sometimes based on the full data set, they are the same amount of data, because if you have different column longer than one, it will have issues. So it's the model basically that knows the features are important. And so your question is saying, if we're predicting for the next year, are we including the year as a feature? No. Okay, if I understand the question clearly, yes, of course. If, for example, using this particular data set, you want to predict the amount this particular car will be sold for the next year. That's if there's a model of 2022, the next model coming out 2023, how much will it be sold for? You still include your year column. Basically, what machine learning does is predicting from past data. That's the past. It's predicting the future. So you still pass the year column. If you have your data set of the cars from the year 1950 to the current year, that's what machine learning does. It will predict all the prices from the previous year and try to predict what the future price will give you. So basically, you still need to include that. I don't know if I'll explain that clearly. Okay, the next question says, please, what was the number of observation? Okay. What I did is, when I said n was equals to 20, I just wanted to, if you know our data set is large, it's 7,250 columns. So I just wanted to get the first 20 parts of it. So even if I decide to get the whole 7,250, it will still show that it was a year column. So to make my visualization clean and fine, that's why I choose n observation to be 20. So it's just like a sample that I selected for that. Okay, another question. Okay, will I go deeper into the models used like the CatBoost and XGBoost? No, I won't. It's left for you to go back to the scikit-learn library to grasp the understanding of these different models. There's the random forest is under the ensemble models. That's the trees. We have the decision tree, random forest regression, decision tree, the extra trees classifier. Then for the boosting, we have the other boost, the CatBoost, the XGBoost, the gradient boosting. So it's left for you to do your personal research on that. I'm not going deep into the theory. So I was supposed to talk on basically linear regression, but for this particular data set, linear regression didn't do it. That's why I brought out this extra algorithm that I use for this particular problem. So that's to answer your question. Okay, train and test part. Okay, this is the training and the test part of machine learning problem under scikit-learn. It's just basically in the documentation. If I explain it, you should try and go back to the scikit-learn documentation. These things are already written there. We didn't create it, it was already, it's part of the documentation. You can go back to the documentation and you understand better. What it does is basically that you have a training set, a test set, and a validation set. So it can be three. It can be a training, a validation, and a test. But what I used was just a train and a test. The training, what I did, I splitted my data into two. 80% was for training the data, training the machine learning algorithm using 80% of my data. Then the testing data was 20%. After training it, the machine learning model with my data, and I want to see if my model was good to test it on this 20% of my data. Mind you, if you have, this is when you don't have a separate test data. This is, for example, if I had a separate test data, I'll just train everything with this particular data. Then I'll test it with the test data. And also, even when training it with, for example, I have a train data and a test data. Inside of my train data, I can see split into train and validation. And after I got in my model, I would now test it with my separate foreign data. So that's why different people in data science, you create models, then you test it with foreign data you didn't get. So I don't know if I've explained more. If you still don't understand, go back to the documentation and understand better. Should you use all the models in every data set to see which one performs better? That is left for you to do if you have a strong competition. If you have, how would I put it? It's computationally expensive in the sense that it runs more on your machine if you don't have a RAM or space or whatever. So it might not be the best method. It's what I just do personally for this data set. If, for example, we have a data set of over millions of rows, if I'm not texting it with this many models, yeah, it will be computationally expensive to test it with this person. That's why you have to know the theory behind it. So I just use this as an illustration. So before this, I can go to the documentation and see that, okay, this algorithm works best for this amount of data for this particular problem I'm trying to solve. I'll just do that. After getting that, I'll do what we call hyperparameter tuning. So I'm tuning each of the parameters in that algorithm to see which one will give me my best answer. So that's just it for that. Then to the next question, how does machine learning model relate to data engineering for those in data engineering track? Okay, in data engineering, you are basically running with creating pipeline for models. It's not bad for you to know machine learning basically, but what you'll be doing is just is to get the data, put it in a good format for the data scientists to work on. And also you'll be working with pipeline, working with Databricks, Azure, and what have you. So you can say it's not that important to your part, but it's not bad to have the knowledge about that. So that's why we just put this part for the stage B for the data engineering also. So it's good you know because once you're working with data, getting a pipeline, putting injection for the data scientist to work with, since you have your own understanding, you can know how to arrange it to set it. My answer will not be the best answer for you. You can also go online and do your research. There's no harm in doing your personal research. There's no best answer or whatever. So it's just for you to do your research. Okay. Any other question? Okay, in the absence of no question, thank you all for joining. Yes, we'll call it a day after this session. I hope you enjoyed this session. And to make an announcement, we'll let you know when you can start taking a quiz after we've done with the upgrade of the platform. We'll let you know. And also, there will be, during this course of the stage B, we'll let you know when you're starting your premier projects. So that will be the next info we'll pass on to you. You are not to join any particular group. We'll be the one to split you into different groups. If you notice those in this new stage, you're already in a separate Slack group, in your separate track. So we'll put you in different groups for the premier projects. More information will be passed on this, you understand. You're not the one to join on any separate group, but splitting you evenly into DevOps, data engineers, the data storytellers, and data scientists. You'll be in your separate group. This is for the premier project, and it's also a compulsory part of the program. So just pay attention on the Slack channel. That's the new Slack channel for those in stage B now. The announcement channel, you'll get all the info you need for that. So for now, just glance through the materials in the course. One you don't understand, you can drop your questions on Slack, or if you are running errors, once your notebook gives you the errors, you can always go online and search that particular error. The concept you don't understand, go more. We are not limiting you to the resources on the platform. You can always do your personal research. There are lots of materials online for you to work with. So basically, it's just for you to have your passion to try to improve more, get an understanding of what this is. So basically, that's it for this session. So the next session coming up will let everyone know the information will be passed on Slack. So always pay attention to that. All right, this will be the end of today's session. Thank you for joining. And of course, my name remains Julo Christian. I'm data scientist at Harmony and assistant program coordinator. Have a wonderful weekend. See you next time. Bye.